couple of general server sizing thoughts, correct amount of processor power, etc. I'm talking about entitlements and so on. Making sure you understand the difference between desired and maximum. I found there's some confusion about this, particularly when you start talking to people about licensing. Desired minimum is what you can't boot without. Desired is what you're guaranteed. And maximum is what you can grow to with a dynamic LPAR operation. Most licensing is based on your desired virtual processors. In some cases, they get very confused, so I tend to set my maximum virtual processors to desired, but just be aware that the licensing should be based on the desired because that is all you can grow to, or to the size of the cap, whichever is smaller. The reason I have the comment about the effect on system overhead is because whatever you set your maximum memory to impacts overhead in real memory. As an example, there's a calculation. Every LPAR has page tables because each LPAR is a virtual memory system. So what will happen is if I have a 4 gig LPAR, but I set maximum memory to 64 gig, it takes the maximum memory setting, it divides it by 64, it then rounds it up to the memory region option size, or what they call an LMB, which could be 64, 128, 256. It's something you have to check in the HMC. And then it reserves that amount of storage of real memory for the page tables for that LPAR. It does it based on the maximum setting because this has to be set aside before the LPAR is brought up. And you could try to do a dynamic LPAR operation to grow the memory. So it says, I'll make sure that you'll never run out of page table entries. So for that 4 gig LPAR, if it had 128 gig of memory, it would reserve 2 gig of memory just for the page pointers, even though you're probably never going to use more than 4. Don't do what a lot of people did initially and set your maximum memory to everything in the box for every LPAR, because all of a sudden you're going to see that 20 gig of memory just disappeared, and you don't know why. And when you go in the HMC and look at the memory being used by the hypervisor, you'll get a rude surprise. So what you want to do, like for that 4 gig LPAR, maybe make its maximum memory 6 gig. Just pay attention to it, and don't forget when you're doing a sizing to include that. You're going to look at shared or dedicated, capped or uncapped. We talked about that, and the number of virtual processors. And it's really important that you don't starve your VIO servers. If you're virtualizing everything, you want to make absolutely certain that your VIO servers have plenty of memory and plenty of CPU. And particularly once you start running 10 gig networking and 8 gig fiber adapters, those add some additional overhead into the VIO servers. And so you need to add additional memory. It's no longer recommended that you run a VIO server with 1.5 gig of memory. I typically start mine with 4, but I do some calculations ahead of time to figure out what the overhead would be if I started to drive those cards. And when I do my sizing, I go, this is what I might need, so I'll include that in the memory I buy. But I'm not necessarily going to put it in there immediately. I'll add it later as I need it. Being cautious of sizing studies, I've seen a lot of them come back. They typically just look at the application and what it needs. They don't tend to include VIO servers. They don't include any memory overhead for the hypervisor. And they tend to miss a few cores. So I've found them sometimes to be off by 4 cores and 40 gig of memory because they didn't include the size for instance, the Oracle SGA. So when you look at a sizing study, make sure you understand exactly what's included, because you don't want to end up in a box that's 32 cores and, 128 gig of memory when you really need one that's 40 cores or even 36 cores, and this box is capped out at 32. So just make sure that you understand what they did size. And another thing I found out was that they don't necessarily test every path that the application code would go through. They test the most commonly used ones. And then my last comment down the bottom about scaling by RPerf, not by gigahertz, when comparing boxes, that really is referring back to the fact that Power 7 is a throughput-based box, as was Power 6. And so you really need to use RPerf, not the gigahertz or the cores, to compare the boxes. So another thing you can look at is adapter priorities. This is an example for a 770C model, and this is just showing you for the actual KEX and for the I/O drawers, the actual adapter priorities. So what we did was we took our most loved ones and we put those in the highest priority slots, and we kind of designed this up front so that we knew exactly what was going there. When you get down to needing very granular performance, you're going to start wanting to do this, and I usually recommend that as a new box comes in, that you basically take care of that and just get it designed up front. Okay, a couple of other points, making sure your page space is correct. There's a couple of things that I'm a big fan of. One is having more than one page space volume. The second one is they should all be the same size. This is because of two reasons. One is that if there are multiple page spaces that are active, if it has to send a whole bunch of pages out, it will send them out in parallel to those page spaces. The reason that you want them to be the same size is because if one of them fills up, then it has to basically redo that page operation because it kind of round robins. So if it's got a lot, it will dump them to all the page spaces, but if it's trying to dump 20 to a page space that's full, it has to go, wait, that's not going to work, I have to go somewhere else. So not only are you paging, you now slowed it down. They should be on different LUNs to each other. That's so that you avoid getting into queue depth problems. And if it's internal disks, you also avoid getting hotspots or having the seek arms moving all over the place. I don't really care if they're on the SAN or on internal disk. The fact that you're paging is something that needs to be addressed, but if you are going to be paging, having multiple of them is a much better thing. The only comment is if they're on internal or non-rated disk, you need to mirror them because kernel pages can go outside of root VG. Now some people comment that they have a very small root VG because they're booting over the SAN, so they're giving themselves 30 gig LUNs, and they can't put a 16 gig page space on it. And that's fine. What you do is leave the HD6 that's small, and at boot time, add an etcrc local into a init tab, and in that, do a swap off of HD6 so that it gets swapped off, and now you have your identical size page spaces that are out there. In terms of how much page space is needed, there are some software vendors that do require twice the memory. Most of them do not. The one that I was aware of, and I think it's still the case with Sybase, and that was because they were doing some things with the page space that I don't really understand. Other than them, I've not come across anybody recently that requires twice the page space. You just usually come up with something sensible depending on how much memory. If you've got 4 gig of memory, you don't need 32 gig or 64 gig of page space. So you need to figure out what's really going to work for you. Okay, a couple of other comments about helping the hypervisor. So when you first define and activate LPARs, that's when it gets assigned where it's going to go in memory and which CPU, and so on. So you can do some things to help yourself so that you don't end up, and this is really important with the 770 and above, so that you don't end up with your LPAR spread across multiple nodes. Ideally, you want to have the cores and the memory that those cores are using very close to each other. And this gets into a whole conversation about affinity and what we call local, near, and far. You want to define and bring up your large LPARs first, and then within the shared pool do the same thing so that it tries to group them together. If you bring up all your little ones first, then what you end up doing is the large one goes to come up and he ends up getting spread all over the place. If you're in that, you're probably in that position already, so there's not much you can do about it, but the next time that you do a firmware update and you're doing a system IPL, that's when you want to look at, okay, what order am I going to bring these LPARs up in? And that's when you want to basically sit there and go, okay, I'll bring my dedicated up, now I'll bring my large shared processor pool ones up, and so on. And then down the bottom I have a comment about memory DIMMs. We used to always try to leave some memory DIMMs free so that you could add memory later on. But if you look at the bandwidth numbers that they publish for memory, that is based on having every DIMM full. And again, that's to avoid affinity issues and so on. So on the 770 and above, that's fine. You can fill them all and use capacity on demand. On the smaller boxes, there's a decision to be made about whether you fill all the DIMMs, whether you have half the DIMMs, understanding that you're not going to get the same memory bandwidth that you would get if you had all the DIMMs full. All right, I mentioned before that there's this thing called a memory region size, or what I refer to as an LMB. If you go to your HMC, you'll see this memory region size. That is actually the logical memory block size, and you see down here it's a different one. In order for me to do live partition mobility between these two servers, I have to have the same memory region size on both. And this is something that gets changed only when you re-IPL the server. So if you plan to use live partition mobility, it's important that you actually set these up as the same number. You can see it's showing me my installed memory, my available memory, etc. And it also shows me my system firmware concurrent memory. That's basically what's currently being used by the firmware. And this is something that you need to know, the memory region size, because you'll use that in calculating memory overhead, and you need to know it for live partition mobility. Alright, so I mentioned that I had a spreadsheet I used for planning for memory. I found this to be a little bit more accurate than the system planning tool, but to give you an idea of what I'm doing here, here's my desired memory for an LPAR, here's my maximum memory setting, I divide it by 64, I then take the LMB, or memory region size, up here and divide it in to figure out the overhead. I round it up, and basically for a 4 gig LPAR, my memory overhead is 256 meg. That's what it's going to take for my page frame table entries. So down here with my one that has 70 gig of memory, my overhead's 1.2 gig, roughly. Now on top of that, depending on whether I'm using NPIV or Virtual SCSI, if I'm using the 8 gig cards or I'm using 10 gigabit Ethernet cards, those are called extra high performance ports. So there's a calculation based on those. So up here I have that I'm using 8 extra high performance ports for my VIO server. So let's say they're 10 gig cards. Each one of those needs 512 meg per port. I basically took that 8 and I multiplied it by 512, and I got for this VIO 4 gig and for the other VIO 4 gig. For NPIV, it's actually 140 meg, you'll see down here, per virtual fiber client. So here I said I've got 12 virtual fiber clients, so that's like LPARs that are being sourced by NPIV per VIO, which is about 1.7 gig of overhead. So what I end up coming up with is that I actually really need probably about 8 gig in my VIO server. Now, that's what I plan for. I give it 3 gig or 4 gig to start, but I plan for it possibly needing 8 gig, and when I do my sizing, I include that memory. I also start out with the Hypervisor needing 768 meg. If you have any integrated virtual Ethernets, which have pretty much gone by the sideway, but if you're doing this for a Power 6, you still have them. Each port that you're using is 102 megabytes. And then they don't publish the numbers anymore, but you used to have to include memory for what we call translation control entries for the I/O drawers. It used to be around 512 meg for every 2 I/O drawers, so I just put that in there as a safety factor. And then I also add a safety net, or what we call a capacity planning fudge factor. So the upshot is that for my 185 gig that I need for this LPAR, I have an additional 6.85 gig of overhead plus whatever I need here for my high performance and NPIV stuff. So I really needed to have 204 gig. So using something like this to figure out what your sizing really should be is a good thing to do, because most of the sizing things do not include the hypervisor overhead. And it's very annoying if you had gone and you had just gotten 185 gig activated and then found out that actually you needed another 19 and you don't have it because you didn't activate it, and so you've got to skinny down your LPARs. So you want to do some kind of planning like this. You can use a system planning tool. Just add a little bit on the end because it doesn't seem to include the I/O drawers or hypervisor overhead. But it's just good to include memory overhead, and then you're not like panicking later because you don't have enough memory.